the first session of today, and Maria is very accurate. You can see she's monitoring up to the last second to start right on time. I'm super excited to be here today to present SQL Server 2016. As some of you might know, before my current role, I was with SQL CAD for about 10 years, and working with customers and partners, right, on their mission-critical workload. And as one of the function for CAD is to be the voice of customer embedded with the engineering team. So we compile our learnings in this red book, green book, because internally we have this binder printout, depends on what color pages are there. We got a red book, green book, we do brown backs, and we walk in the hallways because our office are shared in the office building 35 in Redmond main campus with the engineering team, walking the hallways, bugging people, knocking on their doors. So then about a year ago, when we started planning SQL Server 2016, that time we called SQL Server vNext. We didn't have a name until yesterday. My current boss, Sean, was talking, I bugging him all the time. He said, Lindsay, why don't you just come over to take the lead role for PM role for SQL Server vNext, because we really, really need to go big on the SQL Server vNext, really focus on the high priority customer scenarios. So long story short, and I took the job about a year ago. Now here I am, I present SQL Server 2016. So today this session is the second part of like a continuation of yesterday's foundation session, because we not be able to cover some of the key highlights, right, in the 75-minute session yesterday Sean presented. So we have a part two. We're going to focus on new innovations. So what we're going to have is, there are some of the key features. We have really packed capabilities and features in the SQL Server 2016, right? So since we only really have about an hour, we're going to focus on something new, some new scenarios, right? Like temporal. How can you actually use temporal to travel back in time and to do your data forensics? Combine that with auditing, and our scale-up capabilities, and how can we actually scale right now to actually new highs? Just double what you have, and we fine-tuned a lot of memory accessing technologies, working with our hardware partners, right? And in memory engine advances, column store is fast. I will show you it's even faster now. We can leverage the hardware Intel chip new processor capabilities, goes even faster. And we're adding new workload, like advanced analytics, into SQL Server engine. That's actually makes scale up even more important. Now you make some workload, right, in your same box. So then last, we're going to tell you the list of data track sessions today and tomorrow and Friday. And there's lots of deep dive, more interesting features you will hear from those sessions. So let me start with a little bit overview in the mission critical platform. Yesterday you heard operational analytics, right? We have two in-memory technologies. So we actually integrate them together more closely. And so now you can actually have in-memory column store automatically maintained on top of your row store, just like a secondary index. They're updatable, transparent to your application. So engineering for to make sure there's no impact to your transaction workload. And we added lots of surface area. This is the second version of in-memory OLTP. We did lots of work to expand the surface area. For example, now you're going to have trigger support. And the Mars works now. I know there's lots of application need Mars support. Because with the multi-record sets in your application, you've been using that with your traditional SQL Server engine and with the Hackathon or OLTP. We didn't support it in the first version. So we added lots of surface area. In addition, we rebuilt the engine to make it way more extensible. So you will not see the 256 gigabytes limitation anymore. We can go to more than 2 terabytes of data storage in memory. So you have, say you have 4 terabytes, right? You can use at least 2 terabytes that as the row store for your memory. Use the rest for the working space. Then we added a query store. This is like a flight recorder for your query. You know, we're going to talk like, Burko going to come on stage to talk a little more, drill down on query store, right? It's a flight recorder for your query. And so today, sometimes you upgrade, sometimes your statistics distribution of your data change, the query plan changes, right? And it's very hard to figure out what really happened. And if you call support, then you ask, where's your previous plan, where's your new plan, and compare your plan, try to figure out what happened. And with Query Store, we'll do that for you. And really easily to freeze your plan. If you have a good plan, you can freeze it. And so you don't have to worry about it. No surprises, no those calls in the middle of the night anymore. At least not about the query plan. So security, and we really went big with the security investment in this release. Especially we want to drive toward data continuity into the cloud, and security is super important. You heard the always encrypted. That will prevent man-in-the-middle attack. Let me see a raise of hand. How many of you were at the foundation session yesterday? Oh, so just about 1/3. Okay. So yesterday, we actually demonstrated the always encrypted capability. What it does is today you have TDE, transparent data encryption, right? That will encrypt your data at rest. But when you're executing a query, application run a query, the data will actually get decrypted when they load into memory. And when the results are transmitted through the wire, through the network protocol to your application, they're also decrypted. So that's actually expose your very sensitive data to man-in-the-middle attack if you don't lock down everything. So we're the first software vendor to the market delivering always encrypted technology. What this does is it's a homomorphic encryption. Your data and query are encrypted at all the times on the server. And we have the technology to do computation on encrypted data. So the data will never need decrypted. You will see yesterday there was a demo. Unfortunately, I won't be able to show it right now. It's when your query issued by your client, the parameter will be decrypted through new ADO.NET driver. So the sensitive data, when they come to the server side, will stay as ciphertext. We'll do computation that's including aggregation and range queries on the encrypted ciphertext data. And the data transmitted back to the client, it will get decrypted by the master key only owned by the application. So only the application will see the clear text. So in the case you think your application is trusted and the public cloud or hosted environment is untrusted, in case you know your data could get lost, disk could get lost, your data will be secure because only your application has the master key. So we're super excited with always encrypted. Then being years, I always say it's about 10 years row-level security because every single product planning, release product planning, we put row-level security on top of the list, and they're gradually got to move down, right? This finally, we're releasing row-level security with all the capabilities, including filtering and blocking. And the row-level security will work with all the other new capabilities you heard and throughout this event, right? Including stretch database to the cloud, transparent column encryption, and it will work with all in-memory technology as well. Then dynamic data masking. We see dynamic data masking as the counterpart or the sister features of always encrypted. So always encrypted is you assume you trust your application, you don't trust your server side. And with what the data masking does, you want to share some of your data warehouse, for example, right? Analytics query results with some of your partners. You do want to keep the shape or data type or the statistics, right, of the query accurate. But you may not necessarily want them to see the detailed data. So The dynamic part of this data masking is you can actually define a function of a masking data based on the user policy or user roles. So each user depends on what their permission is. They will see different masked result sets. And this is a function you get to define. It doesn't have to be a fixed, pound sign, then last 4 digits of social security number, for example, right? You can actually transpose the number. For example, the credit card number. You want it to be valid credit card number, so application is still working, but it doesn't have to be real credit card number, right? So you can obfuscate the data based on the user roles, permissions, and its user function you can define. So move on to availability. How many time I already took? Oh, okay, I need to go faster. Availability. So always on, as every release we improve. At this release, there's an exception. We actually added some long weighted features, right? Lots of you been asking for years. For example, DTC support, distributed transaction support. So we now officially support distributed transaction with always on, with added API in the Windows Server. We're working with the Windows Server team now to backport the same API to lower version of a Windows Server like 2012, and instead of just 2016. So you'll be able to run always on supporting DTC in current release of Windows Server. And you can have 3 synchronous failover partners, not just synchronous replicas, right? You can define 3 synchronous failover partners, so you will have higher availability in case one of those synchronous automatic failover partners is not available for whatever reason. And we added this round-robin load balancing to your read workload. Now you can have 8 readable secondary, and before, we always pick the first one. This is not load balanced. We'll do automatic load balancing of the readable secondary, and you don't have to load balancing across all of them. Your availability group across different data center. For example, one of the data center is a DR data center, right? You don't want your load balancing always go to the DR data center be too slow, so you can exclude 1 or 2 you designated as failover or DR data center node. So all that for you. We'll support Windows Server 2016. The online operation, we had a lot of online operation actually enhancement. For example, the outer column online now going to be default. A lot of these online operations are in cloud already, in SQL Azure already. So we're really cloud first. All the surface area, if you go to Sterling, stand up a new database server or database instance, you will actually see this surface area already available. So with that, I'll come to my first demo, which is going to be interesting. It's a scale up. Yesterday, where somebody says, why is this relevant? Because now we're actually putting more and more features into the box. And if we don't fine-tune the memory access, the CPU access, and if you add this mixed workload on your server, it will stress out your 4-socket or 8-socket box. We want you to have the option to have more headrooms. We're working with our hardware partners, both the server partners like HP and also working with Intel, right? We make sure we cannot just focus on the IOPS, because IOPS is completely misleading. IOPS is not the only thing, right? We actually have more and more everything, our data are in memory. So the QPI links, between your CPU nodes, between your memory, actually is more critical for your high throughput, low latency system. So let me show you, we did lots of work to make the performance scalability super smooth. I wouldn't say linear, but we're doing pretty good. While I load that up, I need to figure out how to switch over. Here is 7, I think 7. 1, 2, 3, 4, 5, 7. Okay. So there's a drill down session. My HP partner are delivering right after this. So this is a new HP Integrity Superdome X system is x86 based, 64 bits, have 480 logical processors. So yes, 16 NUMA nodes and 480 logical processors with Intel Ivy Bridge processor with 15 core each. And of course, there's a new processor coming. It'll be a lot more. And this server right now doesn't have 12 terabytes memory in there, have 4. So I loaded it's about 3-point-something terabytes a database. So what I'm trying to do is try to show you how smooth the scaling is with the in-memory, with all the CPU, right? When you have a big box, when you have mixed workload in there, what you really want is you want to use all the CPU resources, all the memory resources, when you actually want one particular workload to run fast, right? Mixed workload. So this database, this is about 4 terabytes, 3-point-some terabytes. The line item, I won't run this scan, actually pretty fast, have about 60 billion rows in there. And let me show you. I bring this back to the NUMA node mode because it's too hard to read. So if I'll show you that, I'll switch, I'll get it run for a bit. So first what I'll do is I'll drop the clean buffer so it will do I/O. I want you to see actually it does I/O really nicely as well. Okay, it will take a while to drop the buffer. So I drop the clean buffer. Now I'm going to run this workload in the, this need to read about 4 terabytes of memory, disk into memory. You can see it's going about 5 gigabytes per second scanning. Because it's have to actually do I/O, right? So you see the CPU not really all utilized because I have scanned the disk. This is through a fiber channel connect to a 3-part storage array. And this, I run this multiple times. It takes about 1 minute to finish because I have to do the scan and do all these aggregation over 60 billion rows. And this is one of the TPC-H queries. It's a fairly complex query. And as you can see, all the CPU are going smoothly, and the I/O throughput is pretty steady, steadying about 5 gigabytes per second. Should be read over about a minute or so. It should finish. It's almost there. What's impressive to see is you see all the 16 NUMA sockets, right? And they all actually being utilized evenly. There's no idle CPU sitting there not doing anything. So the results is coming back. Now they're all in memory. So now let's run this again. So we take the I/O basically out of the equation now, right? So we're going to run the same query without I/O. I want I/O to die down a bit. Let's go. So with optimized CPU and memory access, and you can see CPU get utilized way better. All across 16 socket, 480 logical processors. It's done. 12 seconds. So imagine with our in-memory technology, column store, and in-memory OLTP combination with a powerful machine, very fine-tuned CPU and memory access, you can run real-time analytics, lightning fast. Okay, I'll switch back to slides. So in memory, we have a 2 in-memory engine. One is they're integrated in the same box. When you go install SQL Server, you get your traditional row store on disk, and you get an in-memory engine, which one does OLTP. In-memory OLTP engine is a complete new architecture and has no latch, no locking. It's optimistic concurrency, but we guarantee asset property of your transaction. No data loss, works with always on, and you can have 8 replicas of your in-memory OLTP database as well. And to support your data warehouse workload, we also have an in-memory column store. So for in-memory OLTP, the first thing it does is, because we wanted to target the reduced memory price but stalled the CPU clock speed, so we may memory optimize all your row stores, all your data stores in memory to minimize the IOs, minimize the code paths. So everything is main memory optimized, and in order to actually reduce the consumption of the CPU cycles during the runtime, and we introduced T-SQL compiler to compile your T-SQL to native code. So it's not, you actually don't need to write any different C code for your T-SQL procedures. All you need to do is still write a T-SQL, call it memory optimized, we'll compile it to DLLs. So all your T-SQL procedures are going to be loaded as DLL entries during runtime. And we're very aggressively optimizing during the compile time. And the high concurrency is multi-version. And so there is no locking, and there is no latching. You will not see blocking. So you can see very high throughput with super low latency. There's no lock manager, so everything will go way faster. The code length is reduced about 80% with this engine. And then lastly, we integrate this engine with SQL Server. So all the SQL manageability, availability features just works with it, including security I mentioned earlier. And all the new security features we introduced will work with in-memory OLTP. So column store. Generally, data stored as rows because you're writing data to database a row at a time, or batch of rows at a time. But when data stored as rows, and it doesn't compress as well, right? Because you have more variability across the different columns in your rows. And in order to support higher compression and faster data warehouse type of query, and it's have been very, it's a trend in the data warehouse engine market and the columnar store. So we had a columnar store in releases now. This is the fourth release. Initially, we started with the BI, right? And we store data in column. It compresses super well. It's about 1 to 10 compression. And so you have improved compression and reduced I/O because you have less data pages to load into memory. And therefore, you have better performance. And with the next version, with this version of SQL Server 2016, and we added lots of improvement into the SQL Server column store technology. One is updatable. The secondary column store index on top of your row store is updatable now. So currently, only updatable column store storage in SQL Server is you will convert your entire storage into column store. Do not maintain the row store anymore. But in the mixed workload environment, you probably still want your row store. You really just want to use a column store to speed up analytics query. So we make the non-clustered column store index updatable. So this will allow you to mix your OLTP and your column store storage together and support your mixed workload real time. That's the operational analytics. We added lots of technology to do fast mode, batch processing. We leverage the Intel SIMD vector instruction set to drastically improve query performance. And you can enforce RI through foreign key and primary key relationship on your actual cluster column store. And you can offload your analytics query to secondary now. So I'm going to show you, give you a demo of the performance improvement with all the pushdown, dynamic pushdown from relational engine to storage engine, and leverage lots of Intel hardware capabilities on instruction side. Let me close this one. Where did it go? This one. So the row store query runs, it takes pretty long. So what I did is I run the query before the session start. So the exact same queries, right? The 6-query combination is actually use a different kind of operators. First one have a spools. In the row store, spools actually serialized and it goes a lot slower. And the aggregation function generally in the 2014 are actually in relational engine. And we did a lot of push down, including string filters and non-string filters to storage engine. It will execute a lot faster. So let me show you the new version. Okay. So I want to compare, as you can see, when we built this demo, we didn't have a name. We're still calling it a SQL Server vNext. So in 2014, column store, if I start running this query, you can see the first query, the spool operator is serialized. So it takes about 4 seconds to complete, but still a lot faster, right, than the previous row store. The row store, if I show you again, the row store, the first query took about 4 seconds. The second one takes 61 seconds, almost a minute to complete. So on. So last query takes about 6 seconds. So if I run the same set of query in the SQL 16 column store, both of these two runs right now is code, right? We'll have to read the data from the disk to memory, to the buffer pool. You can see it's already finished way faster, 6 seconds. So we can run this again. Now it's already in buffer pool, no more I/O. There, 3 seconds, all done. So it's changed from about 128 seconds to about 3 seconds. So we added lots of improvement in the engine to speed up your data warehouse performance. That's why we're confident you can add the column store index with your transaction data workload, should not have that much impact to your OLTP workload. So that database actually I listed here is a little smaller than the one, actually way smaller than the one running on Superdome because it's smaller machines. One of those desktop machines we're running it on. So but it have 600 million rows line item. The Superdome one had 60 billion rows. But 600 million rows is not a small database. Now we can run that in just regular desktop machine. So next segment, we're going to change the gear a bit. We're going to talk about deeper insight across data and hyperscale cloud. So we added a lot of capabilities allow you to access data from SQL Server without moving them around. Because data movement actually is generate lots of overhead, really hard to manage, right? Your data is sprawled all over different departments, under developers' desk, analysts have something under the desk. For data scientists, they always have something. Data, we're not very sure, right? DBA not sure what the data scientists have access to your data. And then the internal auditing or external auditing time comes, makes everybody sweat, right? Where the data is. So when we actually added these capabilities, allow you to access data anywhere, will minimize the need to move data around, making copies around. You can access them. So one is the Polybase. Polybase used to be only available with our appliance called PDW. Now it's called APS. And the data warehouse appliance had a region. And you can actually install this technology called Polybase, allow you to access Hadoop data directly without moving them. And we're moving the Polybase technology into SQL Server box just as a feature. So when you install, there's a Dr. DeWitt has a session, I think it's tomorrow, and he will show you how easy it is to set up Polybase. It's when you install SQL Server, there's a checkbox that says Polybase feature. It will install it for you. And currently, we will support 3 distros, actually really 2. One is HD Inside, HDP, they're more or less the same. Then we'll support a Cloudera distro. And you can run T-SQL queries we will translate that to Hadoop jobs. And we'll push the job down to the Hadoop cluster and bring the results back through a streaming interface. Not streaming TempDB anymore. Go through a streaming interface. Have a super fast performance. And we'll add JSON support. We're going to have a native JSON support in SQL Server. So bridge SQL Server relational data to non-relational data. Because the JSON is super popular with the web application. There's not schematized, easy to use. And so we'll add the JSON support to bridge that application interface. We'll add a temporal support. And if you have auditing, and if you have any needs for data that need to be tracked, or simply because you want to mitigate the oops, right? Sometimes application data entry, somebody tapped something in, really just oops. You don't want to go restore everything. If you do a database restore, that's really heavy-handed, right? And this will simply allow your application to do it without calling somebody, bring out the tape to restore your database. I did Power Query for analytics and reporting. We bring that integrating to SharePoint on premises. And you heard the data zone. We actually just completed acquisition for a mobile BI provider, and you will have these very powerful and impressive dashboard capabilities for all devices. We're building analytics, and we added all these enterprise capabilities we needed. For analysis services, now it's NUMA aware, both MOLAP and tabular. And both MOLAP and tabular will support many-to-many relationship. And MDS and SSIS capabilities, and we'll update reporting services. Reporting services is not dead. We will actually update and invest in reporting services, including our integration. You can create customer report through the customer report adapter interface to display the graphics from the R analytics output. You can pipe the data frame directly to reporting services. And the stretch database into Azure. Yesterday, Rohan did the demo, how easy to stretch your table, historical table, into Azure database. Imagine you can combine that with a temporal database. So now if you turn on temporal, and the history database could keep growing, that's internal database, you can move that all into Azure. You still can query it. They're not offline. And we will have the hybrid, the Power BI connect back to SQL Server and analysis services on premises. With that, I'd like to ask Brookle to come join me, talk about query store and temporal database support.
Thank you, Lindsay. So I would like first to introduce myself. My name is Borko Novakovic, and I'm working with Lindsay on next version of SQL Server. I'm a program manager. My team is located in Belgrade, Serbia, in Europe, and we have a fairly big team working there and contributing to the next version of SQL Server and Azure SQL Database. So let's basically start from the problem that we are trying to solve with this beautiful technology. I would like to ask you how many of you experienced serious performance problems and how many of you had to fix and analyze them as soon as possible? Like vast majority of you. So basically you understand what I'm talking about here. Performance problem can be observed in many different ways. The most critical case is actually the entire application or website is down because of underlying database is unresponsive. Also, in some cases, you can experience temporary performance issue, intermittent performance issues. They are come and go in irregular intervals, and you cannot do much about it. You cannot root cause, you cannot prevent them from happening in the future. And finally, some customers also complaining that performance has been degraded after they moved to the latest version of SQL Server. This is really an unfortunate situation, both for them and us. So we know that some of these problems can be caused by query optimizer trying to figure out the better plan, right? And for the most part, it is doing a great job, but in some situation, it can happen that you experience performance problems. But even if you know that query optimizer is root cause for your problems, today with the SQL Server 2014, with the existing server, you will have a hard time to troubleshoot the problems and to fix them appropriately, which means that time to detect and time to fix or mitigate the problem will be very long. And that's really a bad situation. And this is where query store comes into the play to fix this situation, right? And I don't have time to explain how this technology works, but there will be a separate session on Thursday devoted to temporal JSON and query store, and I encourage you to come on Thursday and hear more about details. But with query store, actually, you'll be able to apply different corrective actions for your workload, starting from like tactical, short-term actions, fixing the most important critical queries that are in the problem now, all the way to the longer-term strategical optimization of your workload. In other words, you can use query store to very quickly find and fix the currently the queries that are in the problem at this point, right? But you can also use the query store and the data it collects to classify your queries, to identify the queries that are expensive ones, and focus all of your energy to fix them instead of going through the entire workload, right? You can also use the query store to de-risk maintenance operation, and upgrading to SQL Server V Next is the most important one. So in other words, you can use query store to make migration to the next version of SQL Server smooth and safe in terms of performance. And finally, you can get very deep insights from the data collected by the query store. You can observe and you can identify recurring patterns in your workload. You can optimize not only at the level of a single query, but you can optimize across different queries and across multiple applications that you have. So this is basically what query store provides for. Now I'll basically switch to demo and try to explain and show what you can get with the query store. This example showcases how one can use query store to very efficiently identify problems and fix the most critical problems in the workload with a couple of minutes instead of hours or days, what was the situation before. Here I have a very simple application that is generating thousands and thousands of queries against my database, and this is usually, it really emulates what happens in your environment every day, right? Let me start this application, and let me open the SQL Server Management Studio to see what kind of a new insight you can get from there. Please note that all databases that are enabled for the query store now have new folder under the database node in the Object Explorer, and this is default place for you to go when you need to get performance-related insights. Query store folder contains 4 really awesome new UIs that we built to support this feature. I will focus today on top resource-consuming queries because this is the thing that I want to analyze. I want to quickly identify what is the query that is using the most of my resources. I can adjust this visualization to show only the last 15 minutes for the purpose of this demo. And you can see that actually this UI is divided into 3 parts. On the top pane, you have queries sorted by the criteria that we provided. In the second part, for the selected query, you'll see the full history of query execution plans for the selected query. And finally, you'll have also, for the selected plan, you have plan UI, which enables you to visually identify what happens with your workload. So it's really organized in a drill-down fashion, right? Now, please also know that this UI is very flexible in terms of prioritization and criteria that you want to put for your queries. Like, By default, queries are sorted by duration, which is very intuitive for the most of the users. But you can also specify different metrics, more sophisticated metrics. So you can specify the CPU time, you can specify I/O metrics, you can specify the memory consumption or execution count. All of these perspectives are available because query store is constantly collecting the data every time when your queries get either compiled or executed. Now let's back to analysis. If I select this query, basically from this visualization, I can see that I have one query which is really using the most of my resources. And not only that, this query, SQL Server, during the execution of this query, actually constantly switches between two different execution plans, which is not necessarily a bad situation. You probably know that SQL Server is always trying to find the best plan for your workload based on statistics, based on cardinality and everything. But in this particular case, this is not good because, as you can see from this diagram, the second plan actually has much bigger average duration, and that is not good. That means that for this query, you have a very unpredictable performance. You cannot guarantee. And what you can do you have any easy solution to make sure that all future execution of this query are being performed with a better plan? Yes, you are one click away from that option. Like if I select the better plan and use the force plan button, I can actually do this. Please note that my application is still running, so this change actually does not affect anything for the running workload. But what will happen, actually, SQL Server will use the force plan every time when this query gets executed. Why? Because query store is tightly integrated with the query processing. And every time when query needs to be compiled or processed, query store is actually being consulted. And if there is a force plan, it will be used for sure. So if I refresh this visualization, I can see now that all subsequent execution of this query actually are being performed using the better plan. What does it mean for me if I'm DBA? That means that I have a great UI which allows me in a couple of minutes to understand what is the most critical problem in my workload, and I can also change the way how SQL Server executes the critical query without going into the details. What is this query about? How it's written? And basically without changing the code, which is really great. So I, as a DBA, I do not depend on developers. I do not depend on application vendors to fix the critical queries in my system, right? So yes, this is still force, and this is still being used. There are some other details, basically, but as I said, there will be more about query store in the detailed session on Thursday. Now, I would like to say a couple of things about the temporal database. So before start discussion about why would people use temporal database or temporal features from SQL Server 2016, first, short definition of what temporal is. Temporal data is data that is strictly connected to a time interval. Or time dimension. You can think of temporal as a generalization of the fact table from data warehousing, where basically every row in the table is tightly coupled with a period of validity. And we do believe that record was valid during that period, and some other records were valid outside of that period. Temporal database actually provides you with capability to get insights from your history data very easily, to go back in the past, to understand how your data looked like, for instance, a few months ago, a few years ago, and everything being completely online and transparent for you. So basically, it now becomes clear why people would use temporal, because in reality, majority of the data that we know is actually temporal in its essence, which means data is being data changes, and many businesses rely on insights that can be derived from the data evolution. But traditional databases that we know actually fail to provide appropriate support. And people have to build different workarounds. Usually they build workarounds as part of their application layers. But those workarounds suffer from many different problems. SQL Server 2016 actually comes to solve this situation and to make life easier for many people that would like to deal with time-varying data. We basically envision that temporal can be used in many different scenarios, but the most important are listed here, right? Time travel is ability to reconstruct the state of your data universe at any point in time. It's also ability to compare critical periods side by side and derive critical insights from the difference between the critical periods. Somewhat related to time travel is data audit. Many organizations today are faced with requirements to track full history of data changes for a longer period of time, for a couple of years. And temporal actually helps them because it's designed in a way that it keeps all history changes side by side with the current state of the data. So getting insights from the history data and comparing basically current state of the data and history data becomes easier than ever. We also envision that temporal will help with many different development tasks. One especially interesting is slowly changing dimensions. For instance, if you use temporal, you can completely offload your dimension upload logic from the ETL, from the data integration process, and let SQL Server to take care about all details, right? And finally, I think Lindsay mentioned that as an interesting example. You can use temporal to repair your accidental data corruptions at the finest level of granularity. You can correct a single record with the database being constantly online, which is a really great thing. SQL Server 2016 actually provides ANSI 2011 compliant implementation of temporal, because temporal became part of the standard a couple of years ago. But not only that, because it integrates well with the rest of the SQL Server ecosystem, it actually provides you more and gives you more capability. Here is a typical workflow, or here's a typical situation that might happen in an environment where temporal is being used. Since people would like to keep the history data for many years, what will happen, it will happen that the history portion of the data will become so big, it will become much, much bigger than the current portion of the data. And managing the data will become the nightmare. In the usual situation, in a regular situation, history portion of the data is 10 to 20 times, maybe even more, bigger than the current data. And there is a requirement to keep the history data for 3 to 10 years. But what we observe is that basically people do not query, do not get insights from the history data evenly. They distinguish between the recent history, which they visit very frequently, and old history, which is rarely, almost never queried. Now the question is how we can make a cost-effective solution for customers that do want to have temporal insights, but have a solution which would be attractive in terms of cost and maintenance. And basically, answer is using the stretch table. That was mentioned by Lindsay. Since temporal is flexible enough, it separates the current and the history table in its design. You can separately configure them as stretch tables. You can actually very simple put something like a predicate-based policy saying everything that is older than, 6 months, let it just move to Azure. I don't want to keep it in the local, right? And it will work transparently. Now your workload constantly is running. You are getting more and more history, but actually your warm portion of the history is more or less constant, right? So it's easy to manage, it's predictable, you get great performance. Your cold portion of history grows, but basically cost of maintaining is really acceptable, right? But the beautiful thing is, if you need to query your data anytime. Like if you go to history which affects the cold portion, you can do that without any application change, fully transparently to your application. Basically, you'll have a sense that your data is always local, which is really, really great. That works across regular queries. That works across temporal queries. So that's basically what I wanted to show here. Now let's go again to demo. What I wanted to show here is how one can use temporal to augment the existing auditing story. If you are interested to keep closer look at changes that happen on the critical table, you will probably use SQL Audit that exists in a previous version of SQL Server. And this is actually what I did here. So I configure SQL Audit, and I'm looking at changes that are happening on person table, which is the most critical table in my system. And what I can do, let me see what SQL Audit provides. I have a script here which simulates two users changing the records in the person table. And OK, this is completely fine. I, as a data auditor, would like to have some insights. Right? I would like to understand what happened, when data has changed, who has changed the data. I can run the typical query. This is all existing in SQL Server 2014. This is basically existing today. It's beautiful. I can see that I have two users accessing the person table. I have time when change happened. I have the type of the change, and I even have the statement that changed the data. But what if I could have the exact state of the record immediately before this statement was executed and immediately after that? I could derive more conclusions. I could get better insights because I could understand what was the effective change that was performed in this case. Because in many situations, people and applications are built in a way that they are using parameterized queries or stored procedures. So this statement that I captured here doesn't help me understand what really happened on this record, right? I just know that a couple of fields were changed, but I do not know what happened. And this is where temporal actually comes into play to augment the scenario. I, as a DBA, now have ability to configure temporal feature for my tables. The beautiful thing is, with temporal, you can create new objects as temporal tables. Basically, temporal it's a property of a table. You can have temporal or non-temporal table, right? But also, the beautiful thing is you can extend your existing tables to become temporal tables. And this example shows that, right? I'm adding two temporal properties to my table. One is period definition. Another one is reference to history table, which will be used to keep all changes. I will execute this. And the most important thing you should notice, your existing application won't be affected, because those two attributes are completely maintained by the system, which means your application doesn't need to know that these new fields exist, and they are completely transparent. I will now, again, simulate changes that happen in my now temporal table. You can see DMLs work as expected. Nothing, basically, I don't need to change anything. I had existing stored procedures for modifying data. It just works, right? But now, I have new insights, and I will show you the new insights. I built a simple store proc to basically combine the auditing data that comes from SQL Audit and from temporal. I will show shortly the structure of the store proc, but let's see first the results. Let's see first how this store proc works. If I execute the query, what I have here is, besides the fields that are coming from the SQL Audit, now I have the actual state of the record, which is basically made by this change. And I also can correlate this change with the state of the record that was before this operation was executed. Now I'm able to say this statement actually changed email promotion field from 0 to 2. And also I'm able to say for the second change that the title was updated from the empty value to one of these meaningful values, which is really great. Now I understand what actually happened. You can imagine additional scenario. Let's say that I'm data quality officer. I'm really interested about the quality of the data. I can use the same system to basically detect potential corruption in the data. I'm now executing this as a different user. And yes, so this is the situation that also Lindsay mentioned. Some application or users can change or corrupt the data unintentionally, right? That happens. But I, as a data quality officer, now I have full history in place. I can now do, using the temporal syntax, everything is local, everything is together, right? I can just update the record using the temporal syntax. And this change will be also audited. That means regularly, if that is being audited by someone else, by the admin or security admin, I'll now be able to see what were the changes that my records went through. So this is the beauty of temporal, basically always keeping all changes in place and being available for your analysis. And that's basically what I wanted to show. Now I'll...
Oh. Thanks, Berko.
Thank you.
Thank you, Berko. Thanks. Do you hear me? Okay. So last part of the session, we're on time. We said we're going to leave 10 minutes for QA. And the built-in advanced analytics, we're introducing a new workload called advanced analytics into SQL Server, which is integrate the machine learning capabilities within the engine. It's actually part of the, my machine went to sleep. Part of the effort, how many of you heard the acquisition of Revolution Analytics? So about half of you. So we realized through different surveys, different analysis like IDC, and R have become the most popular language used by data scientists. And in order to do that, right now popular platform is RStudio. And for RStudio to actually run, to do meaningful work, you need to load data all into memory. And with RStudio, there's two limitations. It's single-threaded. Data have to go all load into memory. There's a max memory cap. I think it's about 100 gigabytes. And then the data have to be moved to the station actually where you run R, right? You can run through RODBC is quite slow, but still have to pull data all in the memory. It's not scalable. And internally, Microsoft does a lot of machine learning. And the challenge is always being there's not enough memory space to load the data. Finally, you get memory to load the data, and R cannot handle that much data. Then you get a big box, and it only uses one processor. It doesn't do multiprocessing. So we realized the leading vendor in the market is Revolution Analytics. Lots of large enterprises actually use Revolution Analytics today because they have a technology to actually scale out and streaming the data. One is they can do parallel processing on single node, and they can also do parallel processing scaled out to multiple nodes. And they have a streaming technology interface. The data doesn't have to all sit in memory. They were chunking in the files, and they were streaming to feed the r.exe to run the algorithms. So as we close the acquisition about just last month, we're looking at integrate the Revolution Enterprise into Microsoft technology stack. So Revolution Analytics really have two main line of product. One is called Revolution Open. We call it RRO. And that's the open source version of Revolution Analytics. And it's open source, but it's fully supported. It's validated and supported. And another line of product called Revolution Analytics Enterprise. That is the licensed version of the Revolution Analytics. And that one can scale out to multiple nodes and do parallel processing on the single nodes. So our focus is integrate that into Microsoft technology stack. And the first release we're going to do is we're going to integrate that into SQL Server 2016. So the integration going to happen because the r.exe is open source. So we will actually host r.exe in a separate sandbox process with the SQL Server. And through a new extensibility model we built with the SQL Server, and which I'll show you how very early prototype code, but I'll show you it works. And then you can actually do all your machine learning through T-SQL interface now. You can literally do select and from, and there's a new object we're going to call the table transform. We're going to create a new object type called the table transform in addition to your regular functions and the user-defined functions at type. You're going to have user-defined table transform, which actually going to launch the r.exe process. And then with this extensibility model, you can literally taking advantage of thousands of predictive analytics model out there in the public domain, either from Crane or from our own Azure machine learning gallery. So how many of your company have a dedicated data science department? 1, 2. So from our survey, we realized most enterprises or businesses want to take advantage of machine learning, but most enterprises does not have this dedicated data scientist department, and because data science is very specialized field, right? To take these PhDs to do statistics, machine learning to come up with algorithms. So only very large enterprises have this specialized department. And when they have the specialized department, they generally don't talk to IT. They're part of on their own. And they only go get the data. I'll tell you a true story. Microsoft do have data scientist team. And we have this online commerce department, right? If you go buy Xbox online, then you can go buy music, buy devices, buy what have you. That's our commerce online. And we have a group of data scientists who do modeling, including fraud detection, because the website constantly under attack. And the data science department constantly just want the data from LifeSide. LifeSide managed by DBA, by the operational DBA. Always don't want to give data to them because they always want the real data. They constantly, when they pull data every day, we have the production DBA saw those jobs going because they don't know what the data they want, so they want all of it. They do select star, pull everything, and then the production DBA saw those jobs going, and normally they let it go about an hour, then go kill it, right? Then their phone will ring, and say, what happened to my job? And they say, what are you doing, select star? So it's a constant contention. So we thought, two things we could do. One is we make the DBA's job and data scientist's job better, allow them to run their predictive exploration data analytics at where data it is, right? Instead of a pull data, they have to wait 3 hours. Generally, this model training backwards and forwards take months, right? If they can do it directly with where the data is, save lots of time, save lots of this tension. And the two is we can really actually bring the machine learning to everybody, right? You don't have to, only the few PhDs know how to do machine learning. And we can leverage these new R models in Crane or in a machine learning gallery. And you can actually install that in SQL Server like store procedure, but it's a scripts. Our syntax hasn't get approved by our committee, but basically something look like a store procedure. You can save the R scripts in SQL Server, it will be versioned. And then you can bind that scripts and to multiple transforms, right? You can bind it to one transform for one application. You can bind to another one for different application without actually having to go write the scripts again. So let me move on to demo a very, very early prototype code, because I thought, it'd be good to give you a sense of what we're thinking of. And syntax won't look the same, but the idea represent the idea. What I thought I would do is I will use the very typical iris flowers data sets, because it's a classic data sets used for, sorry, I have to log in. Sorry, I tried to log in, my machine timed out. It's a classic data set for testing machine learning algorithms. And what this is, it's fairly small data sets, have about 300 rows. And it does is use algorithm to classify, to categorize 3 different subspecies in the iris flower. And it depends on the width and the length for the sepal and the petal. And based on the variety of the size of the length and the width, and it will give them different subspecies names, classify them. And we already have lots of existing technology in our platform can actually support end-to-end machine learning experience you have. And of course, as we progress in integrating everything together, you will see machine learning get into Visual Studio. We'll have integration in Visual Studio. We have the new web portal-based Visual Studio product, and to allow you to actually put your R models in there and to run them against the SQL Server directly. And we will put R integration into all our BI product, including Power BI, including Power View, and with SharePoint integration and reporting services. So I did build all these pieces, but we definitely don't have time to go through everything. So I'm going to focus on, show you where I get the model from the gallery and run it in SQL Server. Then you can actually visualize them in Power BI. Let me close this one. Hope I haven't timed out yet. Okay, there we go. So in the Azure Machine Learning Studio, there are literally hundreds of these models. And for serve your whatever predictive analytics tasks you have, right? You can, these are completely community contributed. And you can actually open one and it will open into Machine Learning Studio directly. And so say I'm trying to do a classification of iris flowers. I found 7 of them. Because this data set is very popular, and it's since 1936. It's the scientists have been using it to test the accuracy and the effectiveness of their predictive models. And if you click open that, we just put this in the gallery about last week, because we already have 18 downloads. You can open it directly to the studio. Let me try to open it. Could take a while. I already have one open just in case. Okay. In the machine learning services, you can pick your workspace, right? I created a workspace. Let me open it in there. While that's doing that, so I just opened the one I already opened, and you can run it. Obviously, there's a check mark, so I already run the model. You can run it again, and with this particular model, that's the model I just loaded for. It's a naive Bayes model used for classify your data sets quite effectively. And a part of the data sets with labels, I use that as training, right? And the prediction is add label to the rest of data sets. So since this is already run, let me show you the visualization of the results. With R, the power of R is you can simply use the graphics library built in, do plot. It will plot out your results for classification of all combinations. Fairly hard to read of the different sepal lengths and the petal lengths. And it does cluster my other 150 rows of different flower species into clusters. So it's hard to read. So let's plot out the confusion matrix. Then you can see there are about 6, right? Three in the varicolour, the other one in Virginica have misclassified. Sentosa is doing pretty good. It's 100%. There's no misclassification. Then you probably want to actually look into it to see what else can we do, right? If we can actually look it into a little further. So before I do that, I just want to explain to you, it's really easy to do the same thing. This is the R library used for the naive Bayes library used to do this classification. And the exact same thing, here I created a prediction model. And the second one is doing the prediction. So there are 2 steps, right? With machine learning, generally you do data exploration, create a model. Then in your application, you use that model to do prediction. So we put the same R script into SQL Server. Sorry, I'm not getting too much into explaining the machine learning itself because I have 3 minutes left. So in SQL Server, here's what you'll see, actually. I will explain this a little bit because it's, ignore the syntax a bit because syntax will change. First of all, you can actually configure it. Now you bring this whole machine learning into SQL Server. Machine learning, everybody knows, is CPU and memory intensive, right? What that's going to do with your SQL Server? SQL Server, even you buy a Superdome, all the CPUs, memories, but it could still just run away. So we will put that in a sandbox for you. You can actually you can specify the resource governance information, how much CPU, how much memory you can use, and you can set a security context. So only authenticated user have permission to access data can run this model, access the data. They can run the model, they can't access the data, fail. Then simple thing, you can see this the same package here, and we'll add into from the data frame. What the difference here is I'm reading data now from SQL Server. To the Iris data frame in Azure ML, you can read from SQL Azure as well, or you can read from Blob Store, right? In here, I'm feeding these features from SQL table directly. And I'm telling it this model, what I'm trying to train this model for is to classify the species. And since this is prototype code. Right now, I'm saving the actual model just in the TempDB directory. But in the real release, we will actually have the data structure to host your models inside the SQL Server as data type. And we will understand the data type, and it will be streamed directly. So you can potentially install the binaries of our model and do prediction directly without actually retrain it. And I'll do the same thing since this demo. I will actually use the same algorithm, but I will use the pre-trained model for prediction. So now I have a 2-store procedure or 2 scripts, right? And now I needed to bind it to a SQL Server object to be used for application. So what in this case, I'm binding to 2 table transforms. For the model, I name it the Iris Bayes model. And the second one, obviously, just call it the prediction. That's one I actually used to score the classification. So let me run this. I can show you how simple that is. Oh, I was testing it, so you still see it's there. I need to go up to the top. Here we go. So with the data sets, first now you can actually train the model just by do select statement. You can see that the Iris model is the table transform I created, right? Oh, sorry. I need to start my SQL Server. Minor details. This is early build, so I have to do everything by hand. So the connection failed, perfect, because my SQL Server is not running. Almost there. I'll make this smaller. Okay. Repairing, coming. Okay, now my SQL Server is running. So what this does is now I'm going to run the training of the model select. It will launch R. SQL Server will launch R in a separate process. This is debugging, right? So you see it. Well, eventually you won't actually see it. And now I can run the prediction. See, it classified my labels. Time is up? Okay. So one last thing I will show is now I can check accuracy of my prediction with the training sets. In this case, I'm just going to put in a temp table to compare with my training sets, right? You can see there's exactly 6 misclassified subspecies. So the same model, same data sets in Azure ML, and here you get same results. So now you know it's not fake because I could easily make a 100% match, right? So with that, I'm done. Thank you for coming.